My dear student, I am Rakesh Chaubey. This is the second lecture on the topic physical world for you all. Now my dear, in my first lecture, I have ended up till the gravitational force and electromagnetic force. Now my dear, let us discuss the third basic or the third fundamental forces in universe. The third fundamental force in nature is, my dear, you all know that, and that is nuclear force. The third fundamental forces in nature is the nuclear force. Now today I will discuss with the nuclear forces, and then at the end of the topic we have one small topic, that is what are the laws of physics occurred in nature. That is the laws of physics occurred in nature. But before that, I will complete the last part of the fundamental forces in nature, and that is the third fundamental forces, that is nuclear force. Now my dear, the nuclear force is actually basically, you all know that this nuclear force is between neutron protons. The nuclear force is actually between neutron and proton. My dear, when anybody will ask you, a student know this much, that the nuclear force is actually between neutron and proton inside the nucleus of an atom, because this neutron and proton lie inside the nucleus. Okay, but my dear, this is incomplete knowledge, because there are two nuclear forces. Not all the nuclear forces you'll find inside the neutron and proton. The nuclear forces are observed in one more thing which you are supposed to know in class 11th. So now, and hence I have categorized the nuclear forces in two cases, in two parts. The first one is strong nuclear force. Strong nuclear force. The other one is the weak nuclear force. Weak nuclear force. So now, broad idea of the nuclear force is that, sir, nuclear force is actually between neutron and proton inside the nucleus of an atom. Nucleus में neutron और proton होता है, उसके बीच में जो force होता है neutron और proton के, that is the nuclear force. Student knows this much. But actually, my dear, this is incomplete knowledge, because class 11th says some beyond of it. And how the class 11th define nuclear force is that actually nuclear force is categorized into the two forces which are of nuclear nature. One is the strong nuclear force and other is the weak nuclear force. Now let us discuss first strong nuclear force. So first point I will discuss the strong nuclear force, where it occurred, where you form this, where you get this strong nuclear force. So my dear, whatever you are knowing till now is actually a strong nuclear force. So what you are knowing, that the force which bind, which is there, right? And which force? That is force of attraction. Am I clear? That is, there is a force of attraction between the proton and neutron. Let me tell you, a force of attraction, or you can say, instead of saying a force of attraction, you can say there is a force which binds. What is the meaning of binds? Pakad ke rakhna. Pakad ke rakhta hai. Right? Because see, we say I am very fond of my mummy or my papa, my parents. Why? Because there is some force between you and your parents, जो आपको पकड़ के रखता है, the one which binds you, that is bind. That is meaning of bind. So there is a force which binds neutron and proton. Like there is some force which bind me and my mummy, my parents, right? Similarly, there is a force which binds, which actually there, which exists, जो पकड़ के रखता है किसको? Neutron and proton को. Where is this neutron and proton? They are inside the nucleus. Inside the nucleus. right? So there is a force which binds neutron and proton inside the nucleus, because of which nucleus is stable. Try to understand. अगर ये फोर्स नहीं होता तो न्यूक्लियर इज अनस्टेबल. Nucleus unstable means nucleus get destroyed. What is the meaning of unstable? It get destroyed. And therefore, my dear, what I said, it is very important that there is a force which bind the neutron and proton inside the nucleus, जिसके वजह से nucleus is stable. Am I clear? The nucleus is stable. Otherwise, nucleus become unstable. Am I clear? Why nucleus become unstable? I don't want to go much in deep, because we will discuss all this in the chapter when I will deal with the chapter so-called nuclei in class 12 to you all. Don't worry. But let me tell you, the nucleus get unstable because of force of repulsion. Because nucleus भी एक positive charge है, and there is a force of repulsion by the proton itself. I'll hope you are getting me. So for stability of the nucleus, my dear, there is a very one of the force, and that force is a strong nuclear force. Try to understand. So this is a very important line given in your NCERT also, that my dear, this force is called strong nuclear force. So remember this, that strong nuclear force is responsible for stability of nucleus. Please take care of this line. Here I am writing, this is golden word, that strong nuclear force is responsible for stability of what? Of nucleus. See, try to understand. Atom के अंदर nucleus होता है. Atom is stable, unstable, I am not talking about. Atom is stable, unstable by equal number of proton and equal number of electron. So I am not talking about electron here. I am talking about stability of nucleus. Understand the terms. Nucleus, जो atom के अंदर है, that stability, nucleus का भी stability depend upon this force. If this force is not there, the neutron and proton inside the nucleus will not attract it to each other. They will not bind to each other, and the structure of the nucleus become unstable. So take care of this part, which is very important. Now, second point which I wanted to tell you about strong nuclear force is about its range. Range. कि सर ये कितना strong है? Am I clear? So you should know its range also. Am I clear? So everybody should aware that strong nuclear force का रेंज क्या है. सबसे पहले ये तो बता दिया that strong nuclear force. So again, where this strong nuclear force exists, it exists between neutron and proton. Where the neutron and proton lie, they lie inside the nucleus. What happens if this force is not present? If this force is not present, what happens? Nucleus become unstable. Because nucleus को stable बनाना है, तो neutron and proton should bind to each other. Should bind, and I told you what is the meaning of bind. They get attract to each other. They should bound to each other. पकड़ के रखना चाहिए. They should not repel. They should be bound. Try to understand. Otherwise, the nucleus become unstable. Now the second point is, so please take care of this line, and remember everybody, if anybody will ask you who is responsible for stability of the nucleus, say the answer is strong nuclear force. How? Say this bind the neutron and proton inside the nucleus. But this force is nothing doing with electron. Try to understand, because nucleus is air and atom is air. This is complete atom structure. So if I said this is one atom, here is an electron, and here is the nucleus. This is nucleus. Here is the neutron proton. I am writing NP. My dear, this force is here. You can see in my diagram. So this force is nothing doing with electron. Electron is outside the nucleus. It's around the nucleus. So this force is for neutron and proton. Please take care of this line. This is nothing doing with electron. So your NCERT has written this also. Strong nuclear force don't put any reaction or don't put any influence on electron. So if you wish, I am writing that also, but afterward. Right now discuss what is the range. So you just keep in your mind that sir ये force तो यहाँ अंदर है, neutron और proton के में है, nucleus के अंदर है, right? और electron is around the nucleus. So this force doesn't affect any electron. They don't influence any electron. They are within the nucleus. So if I said within the nucleus, try to understand why I am saying this point. They are within the nucleus. They are within the nucleus. Here it is neutron and here it is proton and this is nucleus. They are within the nucleus. इसके अंदर है. So you can think क्या range हो सकता है. You can imagine what can be a range. A very small range. And जिसका range बहुत small होता है, they are very strong in attraction. They are very strong. Because attraction decreases as the range increases. Everybody can imagine yourself also. है ना? दूर होते जाओगे तो attraction कम होते जाता है. But जितना close हो गया attraction बढ़ता है. That range. So as the range is so small, attraction is so high. You can imagine. So what is the range here? The range of strong nuclear force is of the order of, the student, my dear, there is a method of writing the range. Range लिखते समय we are writing of the order of. Order of means we are writing near about. We are writing, for example, order of always in terms of 10 power. Whenever in physics we write order of is of the order of. So definitely whenever I use the word order, I am interested to write that what is actually a value in terms of 10 power. So it is of the order of 10 power minus 15 meter. Yesterday I told you this is called short range in physics, while discussing a long range and short range. Electromagnetic is a long range. Gravitational force is a long range. But look at the range of this strong nuclear force, 10 power minus 15 meter. 10 power minus 15 meter, matlab you can imagine they occurred for so small 0.00000000015 0 and 1 meter. I'll write 15 0. Now 10 power minus 15, yesterday also I have given the idea. 10 power minus 15 meter, 0.0000000000000. How many times? 15 times. And then here 1, you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and say one more 15 meter. See the range. And my dear, this 10 power minus 15 meter is called 1 Fermi. We call it as 1 Fermi, FM. Fermi, I'll write here Fermi, F-E-R-M-I, Fermi. Fermi, you can see, right? So 1 Fermi is 10 power minus 15 meter. And remember, this is the size of nucleus. The nucleus size is of 1 Fermi, near about. So जितना nuclear का size है उतना इसका range है. Try to understand. 10 power minus 15 meter किसी atom के nucleus का size होता है. That is, we say in terms of Fermi. And minus 15 meter, 10 power minus 15 meter is 1 Fermi, Fermi. Right? Short you write FM. And that is the size of the nucleus. So some of the books say, what is the range of strong nuclear force? The range of strong nuclear force is equal to the size of the nucleus, or it is equal to nuclear size. And what is the meaning of nuclear size? Sir, nuclear size is 10 power minus 15 meter. That is near about 1 Fermi. Answer is 1.2 Fermi. 1 Fermi we say. 1 Fermi. So what is nuclear size? Near about 1 Fermi. So some of the books say 10 power minus 15 meters. Some of the students say the range is equal to the nuclear size. Hence it is called, that is equal to the size of nucleus. The range of strong nuclear force is of the order of 10 power minus 15 meter. And what do you call minus 15 meter? 10 power minus 15 meter means 1 Fermi. And 1 Fermi is the size of the nucleus. The size of the nucleus. So the range of this force is within the nucleus. It's not applicable outside the nucleus, understand? And therefore, hence it does not affect or influence, or it does not have any effect or influence on electron, which are around the nucleus. I hope it is clear. So please try to understand, my dear, the range of strong nuclear force I am talking about. It's a big issue today. You should be aware about it. That range is within the nucleus. That is, it is equivalent to it is equal to the size of the nucleus. That is near about 1 Fermi or 10 power minus 15 meter. Come se come, you remember in terms of number that how much meter is the range. So it is very short range force. Hence it is, you can write, it is short range force. Hence it is short range force. It is short range force. Please. Third point you can write about strong nuclear force. Here I am writing the third point about strong nuclear force. Please, and then I will go for weak nuclear force. The third point on strong nuclear force says strong nuclear force is stronger than whom? Because I taught gravitational force, I taught electromagnetic force, and now I am teaching the nuclear force. Under that I make strong nuclear force. So now the point here is strong nuclear force you think it is strongest in all fundamental forces? Yes. Yes. It is so short range that force that the influence of this force is very strong. Very strong. You can imagine atom bomb. You can imagine nuclear explosions. My dear, itna short range hai ki their influence of exerting the force is very strong. Very strong. And hence, my dear, the textbook said they are strongest force in nature. They are strongest force in nature. I no need to say they are stronger than gravitational force. They are stronger than electromagnetic. They are stronger than weak nuclear. They are strongest. I am using the superlative degree, the third degree. The strongest force of the universe is the strong nuclear force. I hope you understood. Right? Now let's go to the weak nuclear force. Let's go to the weak nuclear force. Now what is weak nuclear force? Now my dear, weak nuclear force, as I said, you have incomplete knowledge earlier. Because people, whenever you ask you what is nuclear force, you are knowing, some of you know, so nuclear force is between neutron and proton. But now today you came to know that, oh God, actually between neutron and proton is just not said nuclear force, it is strong nuclear force. Because under nuclear force there is one more nuclear force, and that is weak nuclear force. And this weak nuclear force you will not observe in neutron and proton. You will not observe in neutron and proton. So where we are observing the weak nuclear force? In the nuclear process. In the nuclear process. Or in the nuclear reaction. In the nuclear reaction. My dear, nuclear process means, if you're not understanding nuclear process, try to understand nuclear reaction. And during the nuclear reaction, some of you know, nuclear reaction, when we say, we are coming to radioactivity. Radioactive elements. Alpha, beta, gamma. If you remember, radioactive. Please, I am uploading this video from my side because I want my kids should be very sharp in every knowledge. We will ask you the question from this chapter, from within this only what I am writing. Your school will ask you the question from this only, because these are the important statements. What is the order? How much will be the order? Then what you can say? Is it equal to the size of the nucleus? Then all, everything what I have written. I'll revise also. But please first complete this. So weak nuclear force is not applicable inside proton, neutron. We are not observing inside proton and neutron. So where we are observing? The weak nuclear force is observed in the nuclear reaction. So I am writing here, weak nuclear force, they are found in the nuclear process or in the nuclear reaction during, remember this, I said nuclear reaction, what is happening? Sir, radioactive disintegration takes place, decay. Radioactive decay. You must be knowing decay. We have doing so much things today for environmental purpose. We say plastic don't decay. Plastic don't decay. Plastic don't disintegrate. So during nuclear reaction, the radioactive elements, which are the alpha, beta, gamma, they decay. They disintegrate. Please take care, decay. Decay का दूसरा मतलब disintegration. I'll write here. So during nuclear reaction, in the process of nuclear reaction, there is decay takes place for radioactive elements. And the radioactive elements are alpha, beta and gamma. So one of this element is beta. So during beta decay means disintegration. Disintegration means if original element is say some X, then it keep on the number, the original element which is earlier is keep on reducing. मान लो पहला element X है. For example, I started with some radioactive element. Like initially that radioactive element when time is 0 is X. But as soon as the time increases, this X will goes on decreasing. That's called disintegration, decay. So you all understood what is decay or disintegration? The number of element keep on decreasing. The number of substance present is keep on decreasing as the time increases. So I'm not going in brief, bache, because again I have to teach in the chapter. Right now I'm teaching overall about it. That what actually. So you should have this much at least in your mind, that there is a nuclear force of kind weak nuclear force, which is not applicable for neutron, proton. It is there in beta decay. And where beta decay takes place? Beta decay is taking place in nuclear reaction or during nuclear process. And your NCERT book has written during beta decay, during this happening, when beta decay was going on, it emit during beta decay, it emit two things. One is electron and other is a kind of energy. Energy is released in the process. Now, if I undergo some disintegration, if I goes on decreasing, there is something evolved from me. Kuch to niklega. So your NCERT book has written there electron and neutrino. Neutrino is a kind of energy. So during this beta decay, electron and neutrino is emitted out. But it is incomplete statement, let me tell you, because beta decay also there are two beta decay. Beta positive decay, beta plus decay, beta minus decay. If it is beta plus decay, it is neutrino. But if it is beta minus decay, it is anti-neutrino. So your NCERT here has given little incomplete. And hence, I am stopping there only. I said only that right now you should aware about this much, that this weak nuclear force is observed where and in what situation. Is observed in the nuclear reaction, during nuclear process. And where? During beta decay or beta disintegration. So this much you should aware of. Am I clear? Rest all further is to be a study of nuclei when you do for class 12. Then you will come to know, because under beta decay also right now it is difficult to say. You will confuse. Because beta decay also there are two beta decay. One is beta positive, that is beta plus, and other is beta minus. Right? So here this is during beta decay, and when I say beta decay, it is beta minus or beta plus can both one. So I am not writing that statement. I said only it is applicable or it is observed during beta decay. And what is beta decay, my dear? This is radioactive disintegration of taking place during nuclear reaction. Okay. So now second point of this is about range. As I discuss here the range, similarly I should discuss the range here also. Now, as I said, the name is weak nuclear force. So it doesn't mean it is weak. Am I clear? It doesn't mean it is weak, let me tell you. It is strong also, little so strong hai. So what actually is the range of weak nuclear force? The range of weak nuclear force is of the order of 10 power minus 16 meter, given in your NCERT book. And this is 10 power minus 15 meter. So thoda bada hai. 16 minus 16. But doesn't mean minus है ना, 16 के आगे minus है, तो जब higher number में minus लगता है तो छोटा हो जाता है, right? So minus 16 is more or minus 15 is more? Minus 15 is more. Minus 15 में there are 15 0 and then 1. Right? In 10 power minus 16 there will be 16 0 and then 1. So of course you can imagine 10 power minus 15 is more than 10 power minus 16. Okay, so weak nuclear force has a range of 10 power minus 16 meter. जो थोड़ा कम है मतलब इससे स्ट्रॉन्ग में कम है. किससे स्ट्रॉन्ग में कम है? स्ट्रॉन्ग न्यूक्लियर फोर्स से कम है. इतना महान नहीं है, इतना स्ट्रॉन्गेस्ट नहीं है जितना स्ट्रॉन्ग न्यूक्लियर फोर्स है. That is weak nuclear force because इसका value is 10 power minus 16 meter. 10 power minus 16 meter, you can see from this example, will be 16 0 before 1 and then there will be 1. So you can imagine 15 0 and 1 and 16 0 and 1. So this will be smaller than 10 power minus 15. So strongest के मामले में, stronger के मामले में ये weak nuclear force is not as strong as strong nuclear force. But my dear, what science says about strongest, about this this weak nuclear force. The third point, please write down this much and then I will continue first. Write down this much from the board and then I will continue the last point of weak nuclear force, the third point of weak nuclear force. Well, for the third point under the weak nuclear force, the third point is about what I discussed. I am writing here because I have to revise everything from the board. I have written third point, they are strongest force in nature. They are strongest force in nature. Who is strongest force? Strong nuclear force is strongest force in nature. Now, with respect to this point, what should be the third point? I said the range is 10 power minus 16. तो यहाँ से ये तो पता चल गया everybody, I hope those who are observing this video, that minus 16 is less than minus 15. Minus 16 less than minus 15 matlab what? The range is minus 16 means it is not so strong as strong nuclear force, because minus 16 means it is not so small range at this one. You can imagine. Right, so my dear, you can imagine this, ki the range of the nuclear force here, the range of weak nuclear force is minus 16 meter, which makes us to understand that it is not stronger than strong nuclear force. Ye to confirm. Okay. Now, but I have taught the two other forces also to you. One is a gravitational force and other is electromagnetic, because I have to compare with all the three forces of fundamental. You know there are three fundamental: gravitational force, electromagnetic and nuclear. Under nuclear I have two forces: strong nuclear and weak nuclear. Strong nuclear is strongest. It is stronger than gravitational, it is stronger than electromagnetic, stronger than weak nuclear, everything. But now, about weak nuclear force, we know it is weak. Therefore, do you think, most of the students think, this is weak, so it is weaker than everybody? No, it's not like that. Because compared to the range of your gravitational and electromagnetic, when you see, my dear, I have written in gravitational it is long range. I have written in electromagnetic also long range. But my dear, as far as the range of this is concerned, it is minus 16, which makes us to understand, sir, it is stronger than strong nuclear, weaker than strong nuclear force, but it doesn't mean it is weak written. It means it is weaker than all the forces. No, please remove this idea from your mind. Don't be in this impression that weak means it is weaker among all the force. No. My dear, it is, I am writing here now, it is weaker than strong nuclear force and electromagnetic force, but stronger than gravitational force. Gravitational force. Please, most of the students have this kind of impression in their mind that it is weak, so it is weaker. Don't be this impression in your mind. It is not so weak. Yeah, your NCERT also have impressed about this line. It is not so weak. Yeah, it is weaker. Fine. It is weak than strong nuclear force. It is weak than electromagnetic force in influencing on the other object. but it is stronger than the gravitational force. So here, my dear, I will make all this revision, and then I will tell you what you're supposed to do. Let's once again, everybody, today I have taught, this video is only for nuclear force. I'm sending it to you all. Now what I said, the third force of the fundamental type after gravitational force and after electromagnetic force is the nuclear force. Make a quick revision. Is a nuclear force, and nuclear force is actually, my dear, in class 11th you'll come to know that, oh God, the nuclear forces are of two kinds. One is a strong nuclear force and other is a weak nuclear force. This weak nuclear force you will not observe everywhere, but strong nuclear force is observed in all the atom. And in the atom, kahan pe? In the nucleus of an atom. Take care. So please have a revision. That strong nuclear force, what you are supposed to say? Sir, this force is binding. Where this force is required? For what it required? It required to bind. To bind, पकड़ के रखने के लिए किसको? Neutron and proton को. To bind the neutron and proton. कहाँ है that neutron and proton? Inside the nucleus. And if this force is not present to bind this neutron proton, nucleus become unstable. So what is important thing? Look at it. ये force नहीं होगा तो neutron proton bind नहीं होगा. Neutron proton bind नहीं होगा तो nucleus unstable हो जाएगा. So ultimately, indirectly, what it means? If because of this force, because of the strong nuclear force, the nuclear structure is stable. ये force नहीं होता तो nucleus stable नहीं होता, and therefore there is a word. Strong nuclear force is responsible for stability of nucleus. Because मैं बार-बार बोल रहा हूँ point, because if this force is absent, so there is no binding, there is no force of attraction between neutron and proton. And the nucleus, जो उसके अंदर जो nucleus, जो पूरे complete neutron proton को जिसको हम लोग nucleus बोलते हैं, the entire nucleus is unstable. Okay. Now the second is range. I talk about range. So what is the range of strong nuclear force and what is the range of weak nuclear force? The range of strong nuclear force is equal to the size of the nucleus. And I said size of the nucleus. What is the meaning of that? Oh God, it is applicable within the nucleus. It is not affecting the electron which is outside the nucleus, around the nucleus. Please take care. This is given in NCERT also. Am I clear? So I hope you are understanding this, that the range of strong nuclear force is of the order of, I have given the in number also. क्या order है? कितने of the order में है? 10 power minus 15 meter. What do you call 10 power minus 15 meter? 1 for me. And this 10 power minus 15 meter 1 for me is actually is approximate value of the size of the nucleus. And therefore some of the books say that the range of this strong nuclear force is equal to the size of the nucleus. क्योंकि इसका value 10 power minus 15 meter है और 10 power minus 15 meter मतलब 1 for me size of the nucleus भी है. Okay. And hence I said, since it is applicable within the nucleus, nucleus के अंदर ही रहता है, neutron proton को पकड़ के रख रहा है. So my dear, where is the electron? It is outside the nucleus, around the nucleus, not revolving. So it means it is not going till electron. Nucleus के अंदर ही रह जाता है. So it is not going till electron, and hence the line said, your NCERT book has written this, it does not affect, it does not affect or influence, don't write affect. It does not affect or influence on electron which are around the nucleus. Because इसका range तो within the nucleus है. So easy. The range is within the nucleus. Then how it will affect the electron which is outside the nucleus, around the nucleus? Now, weak nuclear force? Sir, weak nuclear force are not there in the atom neutron proton binding. No. They are not observed here. They are observed in nuclear process, in nuclear reaction. You must have heard nuclear reactor. And during nuclear reaction or during nuclear process, there was a disintegration, a decay of radioactive elements takes place. Please, I am repeating these words for many times so that you understand. Radioactive elements alpha, beta, gamma, you know. Now during their disintegration, during which disintegration among radioactive में alpha, beta, gamma में भी कौन? Beta. During beta disintegration, during beta decay, when in the nuclear reaction, when beta decay was going on, when beta decay is taking place, that time we observe this force, the weak nuclear force. And due to that, because of this force, the electron and neutrino is emitted out from the process. Electron and neutrino. Neutrino क्या है? Energy है, which will observe in atom bomb and hydrogen bomb बच्चे. I'm not discussing, please don't go in much of it. आपको अभी सिर्फ इतना पढ़ना है. You have to study this much. Oh God, there is this term and where it lie, where we observe. The rest all, we will give a detailed study of this in class 12. Because now if I tell all those things, our other part will be left, which is important with the examination or 11 point of view. And you will confuse also. You just remember this, that this force is not applicable inside the atom. We are not observing this. In the neutron, proton, we are not observing this. They are observed during nuclear process or nuclear reaction. And where in nuclear reaction? When there was a beta decay takes place. Beta decay. Because in any nuclear reaction, there is beta, gamma decay takes place. Alpha, beta, gamma, these are the things taking place. They are radioactive elements. So during beta decay, during the nuclear reaction, when nuclear reaction was going on, there was a beta decay takes place. And during beta disintegration, decay का मतलब है disintegration, we observe weak nuclear force. Second point, weak nuclear force का range क्या है? Sir, the range is near to strong, but it is 10 power minus 16 meter. And if it is minus 16 meter, you can imagine, my dear, you can imagine it is not as strong as the strong nuclear force. You can imagine this. Am I clear? This is not as strong as your strong nuclear force. And therefore, the third point is said, it is weaker than strong nuclear force. It is also weaker than electromagnetic also. And because in nuclear reaction when taking place, the nuclear reaction, the nuclear reaction, the beta decay process, where electron and neutrinos are emitted, my dear, they are not stronger than electromagnetic, let me tell you. Because there is electric and magnetic field, they are also comparably more stronger than the weak nuclear forces. But they are not stronger than the strong nuclear force. Because strong nuclear force is the strongest in the nature. So what is the important one? Weak nuclear force is weaker. Agreed. Don't feel this impression that ki yaar ye sabse weak hai. It is weaker. But it is weaker than only two forces. One is strong nuclear force and electromagnetic force. But it is stronger than the gravitational force. And why this is stronger than the gravitational force? Because of the range. I hope it is clear. And one more thing, the last part which I wanted to tell you through this video, strength of three forces. Here I am writing gravitational force ratio electromagnetic force ratio nuclear force. And in this, my dear, when I talk about the strength, so what is the strength? Or I will write separately. I will write separately for you all. My dear, I am talking about strength of, this is gravitational force, this is electromagnetic force, and this is nuclear force. My dear, electromagnetic force is 10 power 36 times. I am writing like this. 10 power 36 times stronger than gravitational force. Okay, and nuclear force is 10 power 38 times stronger than gravitational force. So if gravitational force is 1, the ratio become like this. Here, 1 ratio 10 power 36 ratio 10 power 38. This is the relation. What it shows? Nuclear force is 10 power 38 times stronger than gravitational force. First point. Second point. Electromagnetic force is 10 power 36 times stronger than gravitational force. And the last, my dear, what is the relation between electromagnetic and nuclear? 10 power 2. Because it is 36, it is 38. So here, nuclear force is the strongest, right? So nuclear force is 10 power 2 times. 10 power 2 matlab 100 times stronger than electromagnetic force. So this I have written strength of 3 fundamental forces. Strength of 3 fundamental forces. So what is the strength ratio? If gravitational force ratio, electromagnetic force ratio, nuclear force is written, then the answer is 1 ratio 10 power 36 ratio 10 power 38. What is the meaning of this? The electromagnetic force, this is 10 power 36 times stronger than gravitational force. What is the meaning of this? 10 power nuclear force is 10 power 38 times stronger than gravitational force. And among nuclear and electromagnetic, you can see here it is 36, here 38, there is a difference of 10 power 2. So I can say nuclear force, no doubt 38 leke bada power mein, so of course nuclear force is the strongest and we studied also. Nuclear force is 100 times or 10 power 2 times stronger than the electromagnetic force. So this is the all relation between all the 3 forces in terms of their strength. So my dear, here I will end with my video. Thank you all. My email ID, you all know that my email ID is Chaube Rakesh Kumar. That's my email ID I am giving you all. Email ID. This is Chaube Rakesh Kumar. There is no space. Rakesh Kumar 011@gmail.com. So if you have any queries, you can put me on my mail any question, I'll keep on uploading my video. After this, tomorrow I will upload the laws in physics, the laws of physics which exist in nature. The laws of physics which exist in nature. That is physics laws. That is law of conservation of charge, law of conservation of mass, law energy mass equivalence, law of conservation of linear momentum, angular momentum. I'll tell you also that which law is natural law. I am calling so much. So name I have given. You know law of conservation of energy. But I will tell you tomorrow in my lecture that, in my video lecture, that which law is assumed as the natural law. It is given in an NCERT book. By that time, read NCERT book on the topic laws of physics in nature or physics laws of nature. There is a topic heading physics laws of nature. Am I clear, my dear? So till that, my dear, I am ending my topic, my video till this point. So here, please try to understand. If you have any doubt regarding this, you can talk to me on my email. Be at home, safe at home. Don't go anywhere. Don't leave your home. Thank you all. Thank you very much. Jai Hind.